All right, if I'm going to take the derivative of this function as it's written, understanding I've got this new rule now, right? Where if the base value is e raised to some power, I know the derivative is going to be that same function times the derivative of the exponent. Let me look at the exponent here real quick and make a note. Eventually, if I have to take the derivative of that exponent, the way that's written, it's written as a quotient. So I'd have to use the quotient rule the way it's written. But we've used little shortcuts in the past where we rewrite these things using negative exponents, right? If I've got 1 over x squared, I understand that means x to the negative second. Right? I understand that I can take that x to the second, I can just bring it up. That will make this a little more efficient of a process when I take this derivative. So now taking the derivative of the function, noting what the exponent is really equal to, dy dx is going to equal, it's e to some power, so taking the derivative here, I start with e to that power. So I could say power is 1 over x squared, I could say the power is x to the negative second, either way. But once I note that, then I have to tack on the derivative of the exponent. So if the exponent is really x to the negative second, taking that derivative, got negative 2x, subtract 1 away to the negative third. And if we don't have to simplify, which at this stage in the game I'm not going to ask you to simplify, that's as far as we have to go. That's our answer. Okay, so we got a function here where if you break it down, you've got a product. So as we take our derivative here, dy dx, it's going to equal, got to use a product rule. So start with the derivative of the first piece of this product. You've got that e to the negative 4x, so derivative is going to be e to the negative 4x, the function itself, times the derivative of the exponent. Exponent is negative 4x. So we're going to multiply on negative 4. Took the derivative of the first part of the product, multiply on the second part, add on first part of the product, times derivative of the second part. So you got a trig function on the second part. Start with the derivative of the sine piece. That's going to be cosine. We write the argument as is. But then, remember, we tack on the derivative of that argument 5x squared, which is 10x. So that's it. We don't have to simplify. All right, so derivative of a trig function, got the exponential function plugged into the trig function. dy dx is going to equal here. Start with the derivative of the trig function piece. Derivative of tangent, what is it? Secant squared. So it's secant squared of this piece that follows the argument, right? E to the square root of x. But then we have to tack on to that the derivative of that e to the square root of x. So using the new rule, we start by writing e to the square root of x because it's e to the power. But you have to tack on to that the derivative of that power. Square root of x is x to the 1/2. Taking that derivative, it'd be 1/2 x to the negative 1/2. That's it. All right, so if you take this derivative implicitly, on the left side of the equation, you got the trig function. So take the derivative of the cosine piece. That's going to be negative sine. And then write what follows. And remember, we got to take the derivative of that part that follows. So derivative of x minus y. As we tack this on, derivative of x is just going to be 1 minus derivative of y is going to be 1 also, but you're taking the derivative of y, so you need that dy dx. That completes the derivative for the left-hand side. On the right-hand side, we do have a product. Got a variable x times e to the x. So using our product rule, take the derivative of x, which is 1, times e to the x, which is the second part, plus first part, x, times, now we've got to take the derivative of the second part of the product. So derivative of e to the x, using the new rule, it's going to be e to the power, right, times the derivative of that power. So power is x, derivative's 1. Meaning from this point forward, if I ever have an e to the x and I take the derivative of it, what's the derivative going to be? It's just itself, right? It's going to be e to the x. Okay, solving now for dy dx. This is where we always highlighted where the dy dx's were. We looked to see what was grouped with those dy dx's through multiplication. Now, I have one dy dx on this problem. It's stuck inside the parentheses, so this meant that whatever was outside the parentheses, we need to multiply that through to actually understand what is being multiplied onto this dy dx. So we take the negative sign of x minus y, multiply that to 1, got negative sign of x minus y. But now take that negative sign of x minus y, multiply to the, what I'm subtracting here, dy dx. That's going to make this a positive. It's a sine of x minus y, dy dx. And then other side is unchanged. You got e to the x basically here, plus x e to the x here. Now highlighting where that dy dx is, looking to see what's multiplied onto it. I can see that the sine of x minus y is multiplied onto it. So I isolate that expression on one side. Anything else, I'm going to move over to the other side. So anything else would be this negative sine of x minus y. Add that over. Now divide through by the sine of x minus y to get your dy dx.